So how, just somebody shout out, even if you've already finished number 7 and 8. What's the first thing we should be doing right here to solve for this? You guys remember? Yep, there it is. So you're going to distribute the 1/2.
Wait, what number is that?
This is number 7.
Oh, wow.
Okay. My computer a little higher.
Disease?
Yeah.
How many questions are we supposed to do? 19?
We're going to go to the end of it, but not till I do all the examples.
No, but how many problems are we doing? 19?
I'll tell you when we get to the end of it, but we're going to go through it together. Because you want to go ahead? No going ahead, unless you want more assignment. All right, let's do this example. So you have your journals. This should be example 5. Is everybody ready? Some of you are facing backwards. Do I need to rearrange again? Thank you. All right, so they tell us the circles are identical. What is the area of each circle? So first of all, area is talking about what part of the circle?
The circumference.
Nope.
Or radius.
Nope. What is the area talking about when you're looking at this circle? What? The inside of the circle. The entire inside of the circle. So you could say it's the shaded part of this circle is the area. Okay. Circumference, which is what you said, is the perimeter, the outside, just the line. Area is all of the inside. So does anybody remember the formula for an area of a circle?
Oh, C.
I see a lot of hands. Somebody say it.
C equals.
That's circumference. We're doing area. A equals.
A equals pi.
Yep, pi is involved. So it's pi times
Is it pi x?
You're all close. Okay, well, okay, so let's do this first. Let's figure out what x equals first. And then it'll show you what pi equals. So we need to find what the radius is. Okay? So does anybody remember what part of this is the radius? Bless you.
Thank you.
What part of a circle is the radius?
From the center to the wall.
From the center to the wall, so half the circle. Okay, so this would be the radius. What about this red line that goes all the way across? Do you remember what that's called? Take a wild guess. Anybody? All the way across, the red line all the way across. What's that called? Diameter. Very good. So the radius is half the diameter. Radius is half the circle. Diameter is the whole across the whole circle. So if we know that this half is x plus 2, how do I find the radius of this one? Close. It's the diameter is the whole thing, so what's the radius? Divide by 2, because it's half. So I'm going to say 4x divided by 2. You can see it up here. 4x divided by 2 equals just 2x. So the purple radius is 2x. And the green radius is x plus 2. Now I can set them equal to each other because they told us at the beginning that the circles are identical, correct? So I can set those two equations equal to each other to solve for x. So I say x plus 2 equals 2x. Now can I solve for x? Yeah. So what would you do to solve for x here? Maybe. You could. I mean, that would get you there, but I have an x by itself and a 2x over here.
Combine like terms.
Combine like terms, so what would I do with this x?
You would add it to the 2x.
I would subtract it because it's a positive. So I'm going to move the x over to the right by subtraction. Write this down. I see a lot of you not writing. So what's 2x minus 1x?
1x.
Just x, right? So then I get x equals 2. which I can flip around and say,
Pi r2.
yeah, so pi r squared was the area of a circle that I was trying to get you to guys say out loud. Pi r squared. So this is why we had to solve for r. So what's the radius that we discovered? Well, up here on the green circle, it would be, what's our x? X equals what? 2. We solved it right here. X equals 2. So 2 plus 2 is 4. So the radius of this circle is 4. So we can plug that in here. Pi times 4 squared. So what's 4 squared? 16. So you could just say 16 pi. So the answer would be C.
Since it's you have to choose a letter.
Correct. All right, so to remind you, you need to also remember the area of a circle. So if you don't have this in your formula, the area of a circle is A equals pi r squared. So put that in your journals so that you remember. And then somebody said the circumference. Do you remember what that one is? Just for fun. Equals.
Pi r2. No.
You have it right. You can put them in any order. 2 pi r. Those are formulas you need to have kind of, you don't have to have them super memorized, but it makes life easier. You don't have to look them up all the time. And remember, area of a circle is the shaded part, where the circumference, it's just the outside. These are things you will need next year in high school, so make sure you are learning them. You'll need them in 8th grade. You'll need them 7th grade. All right, any questions on how we did that? All right, so go try it number 9.
You write that?
We don't have to write the whole thing. You can just write the equation. Oh, let me make this so you can see it. I'll tell you when to write. All right, so a boat travels X miles per hour upstream on the Mississippi River. You see the blue upstream, blue arrow. On the return trip, it travels 2 miles per hour faster. So the green arrow, it only took 2.5 hours because we went 2 miles per hour faster. Now we're trying to find how far the distance is. We went the same distance, right? Upstream just took a little longer because I'm going against the current. So let's create an equation here. So we know the distance is the same. So we can use a variable in place of the distance. So we just put in x. We know the distance is x, right?
Yes.
We know that on the return trip, the green arrow, we went how much faster? 2 miles per hour faster. So that's why you see this x plus 2. So now we're going to write and solve an equation. Here we go. Upstream, how long did it take us? 3 hours. Oh, we're putting it in words first. I apologize. So upstream times the number of hours equal, oh yeah, there it is below. So 3 times how far we went, correct? So 3 times x, or x times 3, however you want to write it. The return trip, how fast we went, miles per hour, times how long it took us. So this one is where we went a little bit faster. So that's why you have the x plus 2 instead of just the x. And then times how many hours it took us. 2.5 hours. I guarantee you're going to have an equation like this you need to solve on your own. So it's probably identical with different numbers. So just make sure you take good notes in your journal on this. All right, so the blue one, we went 3 hours times how far we went, or the rate we went. I apologize. the rate we went, and the return trip on the green arrow, the rate we went plus 2 miles per hour faster times how long it took us. So let's simplify this. So I'm going to distribute this 2.5, correct? So I get 2.5x
Plus 5.
plus 5, because 2.5 times 2 is 5. All right, now what would you move?
You combine like terms.
Correct. So what would we move?
The 2.5x.
I would move the 2.5x, correct. So what's 3 minus 2.5? Correct. 0.5x. And then now to get the x by itself, what's the last step? Divide. So what is 5 divided by 0.5?
10.
Very good. So the boat traveled 10 miles per hour going upstream. Can we guess what we did going downstream?
12 miles per hour.
12 miles per hour because we went faster. So then to convert this to distance, because the question's asking us how far did we go, we have to just convert the hours and cancel out the hours. So we do 10 miles over 1 hour because it was 10 miles per hour, correct? Times the number of hours, which was 3. So it's 10 times 3.
30 miles per hour.
So no, 30 miles. We canceled out the hour. So how far did we go on the boat? 30 miles. We just went upstream in 3 hours and downstream in 2.5 hours. Question.
How do you get 5?
We did the 2.5 times 2. This distributive property right here.
And then 2.5 still stays in?
Yeah, because you did 2.5 times x.
Oh.
Yeah, it feels like a backwards distributive property because the number you're distributing is on the back end instead of the front, but it still works the same. Excellent question. Any other good questions or bad questions? I'll take them all. All right, so then you have, I think, just one more problem. 2 more problems. So you're going to number 19, and that's it for your assignment.